Completing the square is a method for turning a quadratic into a different representation. Okay, why do we want to do that? Well, the standard representation ax squared plus bx plus c isn't particularly useful to us. One of the reasons why is because we have an x squared term and an x term. So if we were trying to solve an equation involving a quadratic, it becomes more difficult, because to solve an equation you really need just one term in its single power as opposed to x squared and an x at the same time. The other thing is that the completing the square format also allows us to identify the turning point, because the completing the square form is a translation format, which we'll talk about in another video. So what do we mean by completing the square? Because it seems a very odd expression. So the first thing I'm going to do is I'm going to explain why it's called completing the square geometrically, okay? So essentially with pictures. And then when we've done that, we'll do it algebraically, which is the way you'd normally do it. Now, as we said, all we really care about is the x squared and the x, okay? The constant we can just leave to one side for a minute, and as long as we remember it at the end, we're fine. So we have x squared and we have 4x. Now, if we draw this, okay, there's an x squared, and we know that would have a side of x and a side of x there. So x times x gives you x squared. Now, we also have a 4x. Now, when we say completing the square, what we're trying to do is work out what the biggest square, the smallest square is that we can put x squared plus 4x into, all right? And it's a bit like Tetris or Lego. So we've got our x squared there, and we've got our plus 4x. Now, if we did a 4x, well, we know this piece is x, okay? And we know this piece is 4, okay? And that's x and that's x, so that gives us 4x. But we haven't created a square, we've created a rectangle if you join them together. And that's not much use to us. So how can we create a square? Well, the solution is to split the 4x in half, which we do as follows. We take this, okay, and we get rid of that, and we go, okay, instead of that, we're going to split the 4x into two lots of 2x. So there's a 2x there, which means if that side's x, this must be 2, because 2 times x gives you 2x. And we take the other 2x and we stick it here. Okay, and we know that's x and that's 2. And the reason we've done that is because if you think about a full square, we now have a side here that is x plus 2. And we now have a side here that is x plus 2. So we actually have a square that's x plus 2 on one side and x plus 2 on the other side. But what's missing, I'm going to put a 2x there. So there's your x squared, there's your 2x. So you've got your x squared plus your 4x, okay? Because you've got this, this, and this. And we've got a square because it's x plus 2 on that side and x plus 2 on that side. But the smarter of you amongst you would have spotted, there's a bit missing, okay? And that is the key piece. So what we've got here actually is we're saying that this equals the same as a square that's x plus 2 that way, x plus 2 that way, minus this little bit in the corner. Now, if you can see from the little bit on this side, it's 2 wide by 2 high. So this is 2 by 2. Okay, and that's all completing the square is geometrically. We're saying, how can we represent x squared plus 4x, or the x squared and the x term, in terms of a square? We complete the square that's big enough, the smallest square that's big enough to hold those terms, but we know we have to take a little bit away. And that's why it's called completing the square, and that's my understanding of it geometrically. Okay? So having seen how we do this geometrically, we're now going to look at how to do it algebraically. And it's a really simple method. The first thing to understand is you can only do it if A equals 1. So what we should realise is that all quadratic expressions have the form ax squared plus bx plus c. Okay, so if a doesn't equal 1, which I'll show you later, we have to do something slightly different. In this case, a does equal 1, b equals 4, c equals -3. But for completing the square, we only care about ax squared and bx. So what do? Well, nice and simple. We create our square straight away. We know there's going to be an x there. And what we did is, remember, we took the 4x and we halved it. We created 2 lots of 2x, and that's exactly what you do here. Whatever b is, you half it. In this case, it's 4. So we create 2. And then we took away that tiny little bit. Do you remember that little bit at the end? We took that away. Now, if you remember, that bit was whatever this number was. So this number here. Okay. And we'd have to use its sign as well. And we squared it because it made that tiny little square, if you remember. And that's it. That's completing the square. Now, that, if you expand it, will give you x squared plus 4x. So I'm going to show you that just so you know, because that's essentially all we're doing. We're representing x squared plus 4x in a different format, but in doing so, we've now only got an x. So if I expand this, okay, I get x squared plus 4x plus 4. Okay, which is why I'm taking away the 2 squared. Okay, because as you can see, that gives me the x squared plus 4x. Now, we've only done the completing the square to replace that. So we need to remember always that there's also, or possibly also, another thing on the end, the constant. So to do this properly, okay, what we need is x squared plus 4x plus 3 becomes x plus 2 squared, take away, and we're always taking away that little square at the end, that there, and then we have to remember this bit, which has to go there. So -3. So the completed the square form of this expression is x plus 2 squared, take away 4, take away the 3, so x plus 2 squared, take away, subtract 7. And that is the completed square form of x squared plus 4x -3. And as you can see, we've done what we wanted. We only have one x value, which means we can do a lot of other things with it. Now, people sometimes get confused about what you take away. Okay, so I'm going to show you an example here of a quadratic where the x term is negative, just to make you understand that the process is exactly the same. But it's very easy to make a mistake here, and a lot of people do for some strange reason. They forget that you're always taking away that little square that's in the corner. Okay, and I'll show you why. So, if we want to complete the square on this, we, first of all, as we said, there's our square. Now, this one has b as -7, okay? And we need to half that. So we half it by saying it's -7/2. We always use fractions, they're just a lot easier, especially as a lot of the results, if we use this in equations, give us surd answers, okay? So remember, that's half, and then we take away whatever this is. And that's why in the last one I said you have to take the sign with it as well. Okay, so hopefully you can see why that's important now. Okay. And then don't forget, as I've remembered, that -9 has to go on the end. Okay. Now the reason I've put this in brackets here, the -7/2, is because when we square it, okay, we're still going to be taking it away. We're always taking it away. Where people get confused is because there's a -7/2, for some reason, they think negative times negative is a positive and add it, okay? And that's, you never do that, right? So now we've got that, we just multiply out what we need to. So this always stays like this, okay, because that's the square bit. And then we're taking away, that's why that. We multiply that out, we get 49 over 4. And there's the takeaway 9. Okay, now whenever b is an odd number, we always end up with these horrible fractions, but then I love fractions, so they're not that horrible. Okay, so minus 7 over 2 squared, take away 49. So we'll put everything over 4. So that means this becomes, okay, minus, oops, what have we done there? Hang on. Why did I put that there? Minus 49 over 4. Where's my keys gone? Minus 49 over 4. Okay, oops. And then we're adding that, aren't we? So that's 36. Because 4 9s are 36. 9 is 36 over 4, isn't it? There's a plus in there because if we're taking away 49 over 4 and we're taking away another lot of 9, then that's the same as actually adding the two together and taking them away in one go. Okay, so you end up with x minus 7 over 2 squared minus 49 plus 36 is 50, 86, 85 over 4. Okay, and if you can simplify the fraction, go ahead. Okay, so negatives, you treat them exactly the same, but do put the bracket around when you square the number, the b at the half of b, okay? But remember, you are always taking it away. And that's the answer to that one. So, what happens when a is greater than 1? Well, as we've said, you can only complete the square when a equals 1. So, we just have to add another step. And in doing that, we make it slightly more complicated, which means we have to be careful and with our brackets. So I don't want 2x squared, I want x squared. So I simply take out a factor of a. Okay, so if I take a factor of 2 out of 2x squared, I'm left with x squared. Completing the square, I do on the x squared and the x term, so I have to take a factor of 2 out of the 6. So that would leave that as 3. Okay, and that's an x there, and there's plus 3 there. So all I've done, as you can see, I've taken a factor of a, which in this case is 2, out of the x squared and the x term. All right? And now, inside that bracket, I have a quadratic with a as 1. So that is why I complete the square on. Okay? Now, the difficulty comes in this case because a lot of people try and combine this step with the next step. Okay? And don't do that. Don't skip it because it's probably where most mistakes are made. Okay, so I now have 2. I have this bracket, and I'm going to make this bracket a lot bigger now because I'm going to be completing the square inside that. So if you remember, to complete the square, we put an x there, we put squared there, we half b, so here it's minus 3. So therefore that becomes minus 3 over 2. We take away the minus 3 over 2 squared. Okay, so you can see now it is a bit more complicated, but only with another layer of brackets. Put the big bracket in, and then we work out what's going on in here. So this is still x minus 3 over 2 squared minus, well, if we square negative 3 over 2, we get 9 over 4. Okay, so we've completed the square on the x squared minus 3x. However, that's all inside a big bracket that we took a factor of 2 out. So now we're able to multiply that by the factor of 2. And this is where the second most common mistake occurs. The reason being that you've got to remember there are 2 terms inside this. Okay, the x minus 3 over 2 squared and the take away 9 over 4. So when you times them by 2, the first bit's easy. You just stick a 2 in front of the bracket. But you have to remember to multiply the second bit by 2. Okay, so that gives us minus 9 over 2. Okay, because you can cancel out the 2 with a factor of 2 in the denominator. That's multiplied the bracket out. So the outer bracket's now gone. And then there's the plus 3. So now we've just got to tidy that last bit up. Okay, so minus 9 over 2 plus 6 over 2, because that's what 3 is, which gives us 2x minus 3 over 2 squared. So minus 9 over 2 plus 6 over 2 is minus 3 over 2. And that's the answer. Okay, so there's one step more, take out a factor of whatever a is, but just be careful with the brackets, okay? You've got to make sure, especially when you're multiplying them out again, so multiplying that out by 2, or a, that you remember there's 2 terms in it. Okay, and that's completing the square.